Hello, welcome to this first Abundomy presentation where I show my free Abundomy assets. In this case, I started with a Roman column, so I'm trying to do some Roman assets like columns and some stones and floors and arches and stuff like that. But I started with the column, and it's free because I think like Blender and like Linux software, but also the assets should be free, so that everybody can enjoy everybody else's work, and we can proceed way faster instead of having this system with copyrights and that just creates artificial scarcity, which basically locks out a lot of people of enjoying these great softwares and assets. How I think exactly about this is I've written down in my book Abundomy, which you can find in the links of this YouTube presentation. In the description, you can see the links to my book, but also the links to this Blender asset which you can download. And this asset is not only generating the mesh of this column, but it also has an export function where you can not only generate all the amounts that are connected to this column, like the volume and the area that needs to be painted, or the amount of rebar if it's in concrete, but also how to export it to, for example, to a spreadsheet, so you can use that data over there. You can even export the parameters themselves, the parameters that are used in this area, in this panel, in this geometry nodes properties panel, and you do that in a CSV in a CSV string, and then later you can get another CSV string of the same column, put it back in your system, and then the exact position how you design this column will be appearing again. So it's not only generating mesh, but it's also giving you the possibility to do, let's say, the cost calculations of, for example, in this example, this column. But obviously I want to do more of these and to create entire buildings, so that you can not only design these buildings in the most efficient way possible, but also get all the amounts that can be used in a spreadsheet, in a cost calculation. And later I will also work on, I call it placeholders, that are used in a full building design, where you can also add, like, say, planning and timing data to that same object. But that I will do that in a later stage. So in this stage, I only it's quite a lot of work. I do the design of the column, getting the amounts and exporting the amounts and importing the CSV string, and that you can all see in the asset, in the Blender file that you can freely download. I use several procedural materials also in this file. So all the materials that you see, you will also find in the Blender files. And I also use a small Python script, which you can also find in the blend file. So everything is there, and I hope you enjoy it. So let me show you how this system works and why I think is the future of construction and architectural design. By the way, I'm working already like 30 years on this concept. My thesis in the university was about how you can connect data to 3D objects. So, and with Blender, and especially with Blender geometry nodes, this is finally possible. So after 30 years waiting, we now have proper software that can do this. at a very good in a very good manner. I hope there will be some additions to Blender that I could really help in regards to exporting data from geometry nodes. That can be a little bit improved, I think, but I am able to work around these issues. But for example, that's why I need a small Python script as well. So without further ado, as everybody says in the videos, we go into this column. You can see it has very fine details. This one is in glass, but obviously I can also use other materials and other designs. So let me go from the top to the bottom, what is going on here. So the first what you see here is is a number which will be used in the construction. If you have a construction file where you have several columns, then you can give them a unique number. For this presentation, I just use number 1. And then you can choose your style. In classical Roman architecture, there are basically 3 styles that are most common. There are a few others, but they are not too common, so I stick to those 3. Perhaps in a later stage I will add 1 or 2 more, but for this, for now, I think this is enough. So you have the Corinthian, which is this column head. You have the Ionic, which looks like this, and the Doric, which looks like this. And then you have the column shape. So these were all round, but we can also have them all in square. And it's all in glass here, so you can't really properly see the difference between round and square. So to see it better, I will go to another material. I got several materials. I got precast concrete. I got normally reinforced concrete. Oh, sorry, this is normal. This is precast. Then I have limestone, marble, and wood. So let me go quickly through them. This is concrete. This is precasted concrete. It's the same color. Then I have limestone. And marble, and I have wood and glass. So this is the material of the column, but I can also make, let's say, a reinforced precast column like this. And you can see it's precast. If you can see the drums, I'll put some drums in there. So you can see there is a little glue line where the concrete is being glued, the precast. But it's not only the outside that I draw, it's also the inside. So when I put on the transparency, you can see that in this column we have rebar. This is precast rebar, where you have these spline sleeves, where you can put glue in to glue the rebar to the column head. But you can also have them, of course, in on-site casted concrete, and then the rebar looks different, which you can see if I change it to on-site concrete. Here you can see this is let's say a normal mesh. And this is all procedural, meaning that when I change the size, for example, I make it bigger, the column, you can see the rebar automatically adjusts to the size. So, and that will save you a lot of drawing work for all these architects and structural engineers that are out there. Obviously, it's still necessary to do some checks on the amounts of rebar and the size, but let's say for a first start and for a cost calculation, this is already quite an improvement in efficiency. So, but let's go to the outside again, because I was talking about the outside. So let me, bring the transparency back, or take it down. Here we have our concrete column, but we can also paint this column. So that's what we do here. I can use a plain color like this. This is the default setting, but we can also use a custom color. So for example, I can choose custom, then I choose a color. Let's say I want to have it like in purple. And I want to have it more rough, so the roughness, so that it's not too shiny. And here you can see a full rough purple column. So you can play with that a bit. So let me go back to the default setting. So this was a default setting. I can also choose a drywall texture, which is white, but you can see it has a texture like this. And all these textures are procedural, so they're all included in the file. As I said, we have a marble texture like here, and you can also change this color of marble as well. So let me see if I can make it darker, so you can see the structure a bit more. So you can see, so if I have a marble that has some purple in it, you can find it here. And this you can also do with the drywall and with the paint, which we already saw. And then I also have like a wood structure, which is here. It's probably more rough. Normally wood would be less shiny. So let's give it a, let's say a 0.4, something like this. But normally wood is more brown like this. So here you can see the wood. So this is how you can create already a lot of different materials and let's say paint and colors. But besides that, we can also change, let's change this to a round one just for fun. And let's go to, for example, these details that we have here. So you can see these columns are nicely profiled. This is all done procedural. And I can even use the gizmos to change these things. So we can do the height with this one. You already saw the column head like this, going back like this. But what is also interesting is the structure here. So actually we can increase and decrease the size of these profiling, and we use a gizmo. The gizmo is like here. So when I use this, you can see these sleeve or these structures are getting bigger, and if I do it like this, they're getting smaller. So we can play with the size, but we can also play with the amount. So if I go back, I can also reduce the amount of structures that I have on my column, or increase it like this. Now, another thing that we can do with these structures is to make them turn. Let me put it on, go back and put it on limestone, because then you can see the structures very well. If I use this, I can also make the structures turn around the column like this to get a very nice effect. I can do it this way, and I can also go back and do it the other way if I want. And if I want to have a straight column again, I can simply go to the twist factor and I put it on 0. So that is how that works. Then we have the diameters. I already showed you this, so we can just change the diameters here. Very extreme if we want to. And we can also introduce or we can work with the drums, the number of drums. The drums are basically the parts of the shaft. Normally the shaft is separated in a few different drums, and to see it very well, I can put it onto concrete, reinforced concrete here, because with concrete you can see these glue lines very well. So here you can see I got 3 drums and they are all separated by this glue. You can also see that the rebar is also adjusted to that. So when I put my transparency on again, you can see that on the inside we have like 3 parts of rebar. If you want to see that better, we can also go to this slider or to this circle, and with this circle, oh sorry, this circle is to do the number of drums. Now it's to be able to, let me put this back on at 3 again. With this number I can also see the different parts. So here you can see the footing, you can see number 1, number 2, number 3, and if I zoom a little bit out, you can see the capital in transparent, but I can also see it like this. So I can get them separate. If I go down, I see them all separate. If I go even negative, I can stack them sort of all together like this. Or Doric. So now, so this is sort of how you build your column, and you can imagine you can have millions or uncountable varieties of these 3 columns already, with all the colors and the sizes and what have you. Now, what is unique to what I add to the, let's say, the parametric, so let's say the procedural system that geometry nodes bring, is that I can also create output, or I added output, and I can show that with this. So here what you see is that when I switch on the object data, I can see that this column has a volume of 0.3 cubic meters. If you want to paint it, you need like 5.3 square meters of paint. The formwork is a little bit bigger, 5.8. The rebar that is in here is 10.3. These sleeves that are used to connect them together is like 22 meters. You need some glue or grout, 45 liters, and when you finish this column, the weight is almost 1 ton. And if I reduce the size, you can see that everything is updated automatically. So if I make it even smaller like this, you can see all the amounts change. Now, what I also can do with these numbers, if I want to see only the material for this mesh on the of the base, I can just select this base with this number here, and you can see that the amounts of this base are also automatically updated. So this base weighs 0.14 ton, like 140 kilos. And when I go up, this all gets adjusted. So, and I think the Doric, the Ionic is the more heavy, is heavier than the Corinthian, for example. You see. So this is all being updated automatically. And that is really the strength of parametric design. So having a system to be able to create mesh is one, but to have all the data connected properly to it is way more important. So now, and if I, for example, if I change the material to wood, you can also see that the weight is much less. So in wood, this would weigh 220 kilos. For example, in glass, it's much heavier. So 0.74 in concrete, it would be normal concrete. It is also almost the same weight as glass. So these factors are also built in the geometry system. Now, to export this, I use a little script. So I can go to the scripting. And here you see a little script where I calculate the amounts that you saw. But I also have the type code. It's called type code, which is basically the description of the column with all the factors. So this is put into the mesh, let's say, is as a named attribute, and the Python script reads these named attributes out of it. And you can see it here. It finds the volume. It sees if it's on metric or empirical. I didn't tell you, but sorry, you can also put this system on empirical. So you have for the English and American people, you have those measures also, which can also be exported by the script, and that is all done here. And then this script results in a little file. In this file, let me show it to you. So this file, and you can see here it's set an empirical measurement system. This is the volume in yards, the paint surface, formwork, Rebar, all this stuff that is in there is being stored, exported as a file automatically here. And there's also a CSV-string generated. This is the CSV-string. And this string describes exactly the column that you selected. So whatever setting that you choose in the property setting, so whatever you choose here, will be put in a little string here. And this is very important because with this very tiny description, you basically can describe the entire column. So if I make a building, I don't need to connect all these geometry node trees to every aspect, every object, but I can just attach, use a placeholder with this string, and when I know the string, I can always go back to the blend file where I generate the column and generate the column again and change, for example, the color or change one of the aspects and then bring it back into the system. It's done this way because I did some experiments, but if you do an entire building with these kind of geometry nodes, it gets too big for almost any computer to handle. So for now, there needs to be a sort of a workaround like this with these strings. So these strings are very important. You can see here that I ignore the strings here, but I can also use the string. And here you can see the string is being copied in and is now being used. So everything that is in here is now used, and everything that is here is not used. So at this moment, the node only looks to the tree, to the string. So the tree only looks to the string, the geometry nodes tree. If I want to change anything, for example, if I want to have another column head, so now I can't just choose iconic. I can choose it, but I also need to use it. So this means that the computer knows that this is what you want to use above the data that is here. So that's why these checkboxes are all here. So, but for now, it's enough to ignore these things. So yeah, I think that is basically it. I think, yeah, so you can also see for if you go to the shading, you can see the different materials that I use. So for example, I use the, let's say, the rebar that I use. So all these materials are made procedural. So there's no texture images I used, which is also very neat because that way all the data is being sort of combined in one blend file. If you use image textures, you need to do a lot of management around these image textures. So that's why everything is done procedural. And all these assets, so all these material assets, these building assets, the geometry nodes, and the Python tool, sorry, the Python script are all included in the blend file. So when you download it, and the link is, again, it's in the description, you can download everything there, and you can take a look at it. You can copy parts out of it. I think a lot of aspects that many geometry node users are struggling with, you will find in my blend file, because a lot of things are solved there. So have fun with it, and if you have any suggestions to which asset I should do next, you can leave a comment in the under the YouTube film. Obviously, it would be nice if you like and share my video and also my files. And what is also important, download my book, which is on the website, that is also in the description, and read why it is important that we all start working like this, and build like a very big library of these assets, so everybody can enjoy not only working with Blender, but also create buildings and other projects, because this is just for buildings, but you can do the same things for furnitures, for kitchens, for artwork, for anything that is basically produced. So if you are a producer, you have a little factory, and you, for example, you are specialized in different types of knives, then we can model them and people can download them and change the parameters in the blend system, and then send you the design file, which you can then import, perhaps through your website even, and do your offers, your financial offers for the project you have. It's a nice way, and I will be honored to help you to create these these procedural blend files, because I think it's necessary that we going to do this this now together with each other, and create a new type of architecture and assets library that is not only used to do video features, but also can be used to steer robots, or to help with production of products. So there's a lot of other applications that can be benefiting from this fantastic Blender program. So thank you for your attention, and I hope you like, share the video, and download the files. And I hope to see you and your comments in the, of course. And I hope to see you in the next one. See you. Bye bye.